December 19th, every major telescope on Earth pointed at Atlas for the moment we've been waiting for. And you know what we saw? A fuzzy cloud. Not the surface, not the actual object, just dust. Because Atlas is hiding behind a veil so perfectly calibrated that Loeb just calculated something disturbing. The dust density is exactly thick enough to block our view. Not too thin to see through, not too thick to maintain, precisely at the threshold of complete concealment. And after everything we've documented about this object, that precision doesn't look like an accident anymore. It looks like a design. Loeb's latest analysis shows Atlas is surrounded by 10-micron dust particles, creating a blanket with a scattering probability of exactly 1.0. That's the mathematical boundary where dust transitions from transparent to opaque. Below that value, sunlight penetrates and we could image the surface. Above that value, the cloud becomes so dense it would suppress further dust release. But right at 1.0, perfect concealment. The dust blocks every attempt to see what's underneath, while maintaining just enough transparency to continue the emission process. Let me explain to you why this makes the artificial Atlas theory stronger. Follow right now so you don't miss Atlas updates. For natural comets, this would be a self-regulating feedback loop. Too much dust blocks sunlight from reaching the icy surface. Sublimation stops, dust production decreases, sunlight reaches surface again. Cycle continues. The system naturally settles at the boundary. But here's the problem with that explanation. It's a remarkable coincidence that Atlas's dust density lands precisely at this threshold. Not 0.5, not 2.0. Exactly at the point of maximum concealment. It's a protective blanket deliberately maintained at optimal density to shield the surface from observation and solar radiation. If you wanted to hide a spacecraft traveling through a solar system while being tracked by every telescope a civilization possesses, you'd surround it with dust calibrated to block optical imaging. That's exactly what we're observing. The size implications reveal the problem. If Atlas is a natural comet with this dust density, the nucleus must be larger than 2 kilometers in diameter for the feedback mechanism to work. But if it's technological and deliberately hiding behind dust, the actual object could be less than 0.7 kilometers, and we'd never see it through the veil. We don't know how big Atlas actually is. The dust hides everything. The Hubble Space Telescope captured the highest resolution images we have. They show fuzzy boundaries, not sharp edges. Webb telescope observations can't penetrate to see structural details. Ground-based imaging with sub-kilometer spatial resolution would still only reveal a diffuse cloud rather than a solid nucleus. The veil works perfectly. Every imaging attempt yields the same result. We're looking at the emission. Cloud, not the object creating it. This isn't equipment limitation. We have the technology to resolve details at these distances. Mars Reconnaissance Orbiter images surface features on Mars from orbit. Hubble photographs distant galaxies with incredible clarity. The issue isn't our telescopes. The issue is that Atlas is wrapped in dust precisely thick enough to prevent observation. Natural self-regulation or deliberate protective measure. Either way, the effect is active concealment. December 19th was supposed to give us answers. Instead, Atlas passed at closest approach, still hidden behind its dust blanket, still blocking our view, still preventing us from seeing what's actually traveling through our solar system. We tracked it for 6 months. We pointed humanity's most advanced instruments at it, and we still can't see the actual object, just the cloud it's hiding behind. 14 anomalies documented. Now add concealment. The dust veil is too perfect. The density is too precise. The timing is too convenient. Atlas doesn't want us to see it. And the math shows exactly how it's preventing observation. Natural feedback maintaining perfect opacity, or protective blanket shielding something that doesn't want to be identified? Comment down your theory. Is it really concealment? Or we lack the instruments to capture a fast-moving object? Don't forget to follow for more.